Hello everyone, welcome back to another video on interview preparation. In this video, we will discuss the top microservices design pattern interview questions and answers. These are frequently asked interview questions for experienced Java developers. Let's get started. Explain the API gateway pattern and why it is important in microservices. The API gateway pattern is used as a single entry point for all client requests in a microservices system. Instead of clients calling multiple microservices directly, all requests go through the API gateway. The gateway then routes requests to the appropriate backend services. This simplifies client-side logic and hides internal service structure. The API gateway handles common concerns such as authentication, authorization, rate limiting, logging, and request validation. This prevents duplication of these responsibilities across multiple services. Another important role of the gateway is request aggregation. Sometimes a client needs data from multiple services. The gateway can combine responses and return a single result, reducing network calls. Without an API gateway, clients become tightly coupled to internal services. Any service change can break clients. The gateway provides a stable contract and protects internal services from direct exposure. In interviews, experienced developers are expected to explain that the API gateway is not just a router. It is a boundary that improves security, scalability, and maintainability in microservices systems. Poorly designed gateways can become bottlenecks, so they must be lightweight and carefully designed. Next, what is the circuit breaker pattern and how does it prevent system failure? The circuit breaker pattern is used to prevent repeated calls to a failing service. In microservices, service failures are inevitable. If one service becomes slow or unavailable, continuously calling it wastes resources and spreads failure across the system. A circuit breaker monitors service calls. When failures exceed a threshold, the circuit breaker opens and blocks further calls to the failing service. Instead of waiting for timeouts, requests fail fast. After a cooldown period, the circuit breaker allows a few test requests. If the service recovers, normal traffic resumes. If not, the circuit remains open. This pattern protects thread pools, prevents cascading failures, and improves overall system stability. It also allows dependent services to continue functioning, often using fallback responses. In interviews, experienced developers are expected to explain real failure scenarios where circuit breakers saved the system. Interviewers want to hear why failing fast is better than waiting and how circuit breakers change system behavior under stress. Next, explain the Saga pattern and how it handles distributed transactions. The Saga pattern is used to manage distributed transactions in microservices. In microservices, each service has its own database. Traditional database transactions cannot span multiple services without tight coupling. The Saga pattern solves this by breaking a transaction into multiple local transactions. Each service performs its operation and publishes an event when it completes. Other services react to that event and perform their own operations. If one step fails, compensating actions are executed to undo previous successful steps. This ensures data consistency over time rather than immediately. The Saga pattern supports eventual consistency and avoids locking resources across services. However, it requires careful design. Services must be idempotent and compensations must be reliable. In interviews, experienced developers are expected to explain why traditional transactions do not work in microservices, how sagas reduce coupling, and what complexity they introduce. Interviewers often look for real examples, such as order processing or payment workflows. Next question: what is the database per service pattern and why is it critical? The database per service pattern means each microservice owns its own database. No other service is allowed to access that database directly. This ensures strong service boundaries and independent evolution. If multiple services share a database, they become tightly coupled. Schema changes in one service can break others. Deployment becomes risky and slow. With database per service, each service can choose its own data model and scale independently. Failures are isolated. A database issue in one service does not directly impact others. The trade-off is data duplication and eventual consistency. Services may need to store copies of data owned by other services. This increases complexity but improves scalability and resilience. In interviews, experienced developers are expected to explain that this pattern is foundational for microservices. Interviewers want to hear why database sharing breaks microservices and how data ownership improves long-term system maintainability. Next question. Explain the event-driven architecture pattern in microservices. Event-driven architecture is a pattern where services communicate by publishing and consuming events instead of calling each other directly. When something important happens, a service emits an event. Other services react to that event asynchronously. This removes direct dependencies between services. This pattern improves scalability and resilience. Services do not wait for responses and are not affected if consumers are temporarily unavailable. Events can be processed when resources are available. Event-driven systems are ideal for workflows, notifications, analytics, and integrations. However, debugging becomes harder because execution is distributed and asynchronous. Observability, idempotency, and proper error handling are critical. Without them, event systems can become unreliable and difficult to maintain. In interviews, experienced developers are expected to explain when to use events instead of synchronous calls, what problems event-driven architecture solves, and what new challenges it introduces. This shows architectural maturity.